This project is part of a larger collaboration between the National Research Council of Canada and Concordia University, aimed at automating the design of modular building layouts. The automated space layout planning application begins by gathering essential information from the client or designer. This input is validated against Ontario Building Code and the Design Requirement Manual, ensuring compliance from the outset. If any parameters exceed limits or if capacity remains available, the system alerts the user and provides options for modification. The system generates all possible spatial graphs. Each configuration is evaluated for spatial quality and circulation flow, with the most promising arrangements selected for further refinement. From here, the focus shifts to manufacturing feasibility. Every possible module combination is generated and assessed against manufacturing and logistical criteria. The configuration with the lowest penalty score is chosen, after which multiple orientation scenarios are tested to ensure the winning combination fits seamlessly within the given land size. The selected graph is then integrated with the module configuration, bridging spatial and manufacturing requirements. To generate the initial cell layout, the system employs cellular automata, expanding step by step from a primary seed cell according to defined priorities and rules. Any conflicts are resolved through targeted space swapping, preserving functionality. An optimization process then fine-tunes the form and circulation, smoothing transitions and enhancing overall performance. Finally, the fully optimized 2D layout is transformed into a detailed building plan, one that is ready for both design and manufacturing. This application has been validated using a model from the Ironwood Modular Company, confirming its feasibility.